generative content in the computer vision field. Then we will see different applications. And next, the advanced models. What are the advanced models? After this workshop, you can pick up and start working on them. And also, we have some hands-on experiment on the collab. And also, I will provide some resources. And finally, we will conclude with the conclusion. Okay. So everything is clear. So
Yes.
first of all, we will understand what is computer vision. So basically, computer vision basically means whatever the humans will perceive with the eyes, like vision, like how we will provide the vision to the human computer. Like if that data was anything like images, videos, or 3D models, or any GIF files, or animations, vectors, anything. So whatever our humans will conceive with the um, our eyes, we will make it as a very useful for the system. Like how we will give that data with the data to the system. Okay, that how the computer actually understand the vision of the humans. That's a basically computer vision. So we will see some of the classical computer vision models. What are the how the classical computer vision models will work? What is their applications? So in classical computer vision models, we have different models like object detection, semantic segmentation, image classification, optical character recognition, face recognition. We have so many other classical computer vision tasks also. So we will see some examples for them. So if you see here, if that image was classified as a dog or cat, some animals. So you have a bunch of images. You have to classify what is the content in that image. So image classification will comes place into that place. Then next, object detection. Object detection basically means if any image have particular object in that image. So most of the object detection algorithms will use in traffic lights, like a person was wearing helmet or not, or in industries also to find the damaged products or in the conveyor belts like that. And next, semantic segmentation. Semantic segmentation and the instant segmentation. These two are extensively used in self-driving cars. So a lot of the self-driving cars has the that inbuilt cameras. So they will use sensor fusion technology to detect the lidar data, and also from they will get the data through the cameras also. So with that data, you will clearly distinguish between what is the object in front of the car, like if it was a person or it was a vehicle or something. So if you see here in object detection, you will get this kind of boxes. In semantic segmentation, you will distinguish between different objects with the different colors. So if you can see different other examples also in the below row. Now we will see what is generative computer vision. So generative computer vision basically means we will create the new image or video content based on the existing samples. So if you already familiar with any classical computer vision tasks, they are not generating any new content. They are simply processing the what is the image you are providing. It will automatically detect the object or classify the object, something like that. It will not create any new image, new video, new things or anything. So if you take the generative computer vision, here you can have different types of input. Like you can do text to image models, you can do image to image models, you can do style transfer models, you can do text to 3D models also. So like that, you have different approaches in the computer generative computer vision. So basically, there are three main algorithms we will use for the generative computer vision. One is generative adversarial networks. We call them as a GANs. And second one is variational autoencoders. And finally, diffusion models. So these three main algorithms will play a lot of roles in generative computer vision. If you take the classical computer vision, in classical computer vision, we will use the convolutional neural networks. We call them as CNNs. But in generative computer vision, we will have extensively use these three models. Now we will see how actually these three models actually we will use. So generative adversarial networks basically means it have two networks inside the complete model. One is generative model, one is adversarial network. So these two networks are always check with each other. Like I will show you one example. So if you see here, this is the generative network. This is the discriminative network. Okay. So first of all, we will feed the images into the generative network when we combine the image features into low latent space. Latent space basically means we will convert the image into some array format. Okay. So whenever we convert the image into array format, we will give that data to the training for the model, where the generative network will work. Then high dimensional sample space. High dimensional sample space means we will give the images normally, plain images, real images. Now, what the generative network will do was it will simply generate a image. Now, once it was generated, the discriminative will network will distinguish between the original image and a generated image. Like it should be almost closer to the original image, but it should not repeat the already existing trained image. So that is the task for the discriminative network. Okay, this is how the GANs will work. Now we will see. Sorry. Now we will see variational autoencoders. So variational autoencoders basically what they will do is they will have series of layers where they can encode the image data into low dimensional data. Low dimensional data basically means whenever you encode the image into array format, whenever you pass that array through multiple layers of the deep neural network, it will squeeze the features of that image into low latent space. Low latent basically means small number of array states. Okay. So once that was achieved, we have decoder network where it will automatically decode that latent space into the original image. This is how it will work, like from left to right. So in this network, how it will do is whenever you given any prompt, it will start from the latent space. So it will generate first of all latent space. From the latent space, the decoder network will automatically decode that latent space, then finally generate the image. So these are the two approaches. And final approach is diffusion models. So in this diffusion models, what the network architecture is, first of all, it will take any input image and it will start adding the noise, some random noise. Okay. So once the noise was added, then again it will pass to the next layer. Like that, it will add the more and more noise till it will completely become a pure noise. So once it will become the pure noise, from this pure noise, it will try to regenerate that image. Okay. So like that, it will create a image. So whenever you given any prompt, it will take some random noise. From that noise, it will try to generate a new image. Like that, this algorithm will work. Okay. So we have three types of networks. One is generative adversarial networks, one is diffusion models, one is variational autoencoders. Okay, so these are the main key fundamental blocks for the all of the generative computer vision AI models. Like if you take any stable diffusion, Dolly, or Midjourney, or if you see a lot of the video generation models also there right now, like Runway, um, and OpenAI also recently released one video generation models, Sora. So like that, all of these generative models, basically they will use in the core fundamental blocks, they will use any of these models. So these are the basic building blocks for the any computer vision generative models. Okay. So, okay, what is the applications of the generative AI computer vision? Okay, first of all, art and design. So creating new artwork and visual content and designs. So if you take any example of any graphic designer or some artists, so for example, you want to create your image in Mona Lisa art style. So for that, you have one model. So for example, you want to create a some poster in Lego style. So in that case, you will spend a lot of time. The designers will spend a lot of time to generate that kind of art, and also there are some misperfections also there. They will not able to create that one, and also it will take a lot of manpower to generate that art. So to reduce that burden on the designers and also to increase the creativity levels of artists, lot of art and design models also available out there. Like one of the examples, stable diffusion. Sorry. So stable diffusion is open source model, like anybody can use for their experiments. You can find that model in the Hugging Face. We will see some demo also. So, and also in entertainment. So if you see a lot of posts in recently in Instagram or LinkedIn or in YouTube also, a lot of the people are generating the content using the this kind of generative AI models. Like they are creating their own avatars for their content generation, and also a lot of image to video generation also. Like for example, uh, if two persons are sitting side by side, you can make them walk like a natural video. Like that, image to video models also out there. And next is healthcare. So in the healthcare, how this generative AI model was using was, for example, if you want to train any image classification model, or if you want to create segmentation model for detecting brain tumors or classifying the X-ray images or something, the data is very sensitive. Like a lot of the hospitals or a lot of the patients are not okay with the sharing their data to the research purpose or something. So how this generative AI actually helping researchers was using the synthetic data. Like first of all, we will take some sample images from the hospitals, like 10 or 20 images. So based on that images, we will populate that data set. So automatically it will populate, we can populate the data set and also create the new data sets for the research purposes. So in this case, there are a lot of medical advantages also there, and also prediction of these diseases, and also creating diagnostic reports are also very high. And next, data augmentation. So data augmentation basically means whenever you have some kind of data set, you want to manipulate that data, like a so one second, like a rotate the image, like resize the image, or else crop the image. Like that, data augmentations we will use to do in classical computer vision. But with this generative AI, we can literally create thousands of lakhs of images with the simple prompts. Like, for example, if you want to predict an apple was um, completely eatable or it was still need to be ripe. So, for example, if you want to train that kind of model, you don't have to take the multiple images of the apple. You can simply give an image and prompt like create an apple images with the this kind conditions, and it will automatically create different images. Then you can automatically label those images and train that kind of model. And also image to image translation. So image to image translation basically means, for example, if you see some photo or some advertisement in any website or any Instagram post or any Pinterest post. You want to create that kind of style and ambience and that kind of environment. So in this case, you can use image to image model. So in this image to image model, what it will do is it will take one image as a reference, and based on the prompt, it will automatically create that kind of styled image. So that is image to image model. And next is super resolution. So super resolution basically means, so for example, if you have any old pictures or some damaged pictures of your grandparents or your old photos or something, you want to make them as new. Like you can increase the resolution of those images, and also you can convert the black and white images into color images also. Like that, there are thousands of use cases in cinema and photo industry. And also style transfer. Style transfer basically means, for example, if you like that one painting style, you want to apply that kind of painting style to your image, or you want to create some poster with that kind of style. So in that case, you can create those things. So these are the all of the applications. Okay. Now we have another advanced models called control X. So control X basically used for the to guide the image. So for example, like in the LLM models, we have hallucinations happen in generative computer vision models also. In that case, we can use the control X. So control X basically how they will work. You will give some guided image to the model. It will automatically create that kind of image. So I will show you some examples also. So IP adapters. IP adapters is basically used for the changing the style of the image. Like you can literally change the style of the lighting style. It can be natural light, it can be studio light, or it can be change the complete environment, those things. And this automatic double one double one, this is one of the GitHub repository where you can try the multiple generative AI solutions in their GitHub. And also focus also one of the other GitHub repository where they can provide different kinds of styles, different kinds of image generations, those kind of things also. So I will just open my browser and show you how you can do this. So this will provide the some web user interface for your experiments. So if you see here, you will get the user interface like this. So you have multiple models, text to image to image, and extras also like background removal or foreground removal, those kind of things also. You can change the resolution also here, how many number of images you want to change. So actually, if you want to run this model, you have to have some GPU also. So you can try to run it on Google Colab also. So they have provided a lot of features like you can try stable diffusion models also. In painting models also you can use. So like this, they have provided all of the installation instructions also. So you can go through this GitHub repository. On one of the other GitHub repositories, Focus. So this is one of other GitHub repository where they can provide a lot of resources for the generative computer vision models. So these are all the images are generated images only. Okay. So they have multiple options to set up the repository. They have direct .exe files for the Windows users also. You can check that one also. So if you click here to download, it will automatically start the downloading process. They have all of the instructions to generate those images. Okay. Now we will see how actually we can find any uh, generative computer vision model. So for example, if you want to achieve something, for example, I want to remove an object from the image. So how you will actually search that kind of model? So basically, you have to understand what is the terminology used in computer vision. Like if you want to remove any object, it's called in painting. Okay. So for example, if you want to remove any object or if you want to add any object, we call them as a in painting models. So you can simply go to the Google and image in painting GitHub. You can just type that. It will give a lot of the in painting repositories. So this is based on the Llama in painting model. So Llama is the another in painting model like a stable diffusion and mid journey. So how they will actually work was, sorry, once you set up the repository in your system, you can give the um, image to the script. It will automatically remove the objects. It will automatically add the objects based on the prompts you will providing. Okay. So if you see here, they have selected this person as a to remove the object. It will automatically segmented this part and it will remove that completely. Okay. So there is another most popular generative computer vision model from the metaverse, segment anything. So that segment anything model actually works like a charm. So for example, if you want to segment any part of the image uh, from the for the desired outcome, you can literally do that. I will show that demo also. So this model actually from the Meta. So why we need segmentation in the generative computer vision? So for example, it's not only stopped with the only generating the image. For example, the user wants to change in the image. Like for example, I have generated a car. So I want to change the types of the car. So I want to select the car types. How I can select? I can simply click and create a mask around it. So using this kind of in-painting model, I can automatically change the types of the car. So if you want to segment anything inside the image, you have to use some model, something like this segment anything. Okay, I'm clicking try demo, upload an image. Okay. So I'm uploading my image itself. So let me see how it will actually do that. So if I want to create a mask, I can simply, if you see, it's already processed. I can simply click the image and create a mask. And if I click the background, it will create the 1 second. So if you click the everything, it will create different masks for the entire image. If I click the cut all, so like with single click, it has created masks for my shirt, my pants, and also background banner also, face and tag also. Like that, it will create the mask for the each and every part of the image. So using this kind of semantic segmentation, you can add the other contents using this kind of inpainting models. So if you see, you can remove the some objects in this things also. If you see, a lot of these features are already available in the iPhones and Pixel phones also. Like if you tap and hold on any object, it will automatically detect the what is the area you want to actually remove or what is the thing you want to actually add. So all of those features are work with these kind of algorithms only. So you can replace the objects also. Like first of all, they're trying to segment the dog. Then they try to replace with the teddy bear. So here, this is the original image. They have created the mask using the segment anything model. Then they given the prompt like a camera lens in the hand. Okay. So they have created some lens. Like that, you can create those things. And after that, how you can actually find the all of the models. So I think you guys are already familiar with the Hugging Face. So Hugging Face actually very popular website for the generative AI solutions, where you can find the lot of open source models. So it's like a second version of the Kaggle, you can say. So Kaggle basically used for the classical AI tasks like classification, clustering, and all of those things. But if you see Hugging Face, they have multiple features like models. If you go to the models, you can find a lot of things related to generative AI and classical AI also. If you see multimodals basically means you can use the text and image also, so you can give the image and you can answer the questions about that image like that. And also you have computer vision models. In vision models also you have multiple things like depth estimation, image classification, object detection, text to video, image to 3D, text to 3D. Like this, you can find the different models available in there. And if you use the text to image, we will try to do the text to image today. So you can see a lot of the available models which are already available for the people to use. So Flex is the most popular model, but it will require some amount of GPU. So I have taken the some other model. Just give me 1 second. So if you are already on your systems, please open any collab collab notebook and you can code with me along. It's like simple script. You can generate your own image and I will show you some demos also, other demos. So I'm sharing this link in the card section. 1 second. So just open that link. I will guide you through how we can do this image generation model. Once you open that link, I will provide these comments also. So what you have to do was for some models, you have to create the key access token for your model. I'm using open source model. For example, if you want to use the stable diffusion or flex model, you have to create your own key. Okay. For example, I go to the text to image and a flex dev model. So actually, it was gated repository. If you want to see your gated repositories, you can go to the settings, gated repositories. So I have gained access to the all of these repositories. So you have to request for the access. Once it was approved, it will showing like this accepted. If it was still on process, it will show like pending, like this. So once you have gained the access to any of this model, you can simply go to the access tokens and you can here create a new token here. So from the token, you can automatically get the token from the Hugging Face. So once you get the token, you have to include that token inside your Python code. Then you will get the uh, access to the model. So I will run this from a new file because I will show you, guide you through how you can create this one. So I'm creating new notebook. So once you have created the new notebook in Collab, so Collab basically means I think you guys are not familiar with the Collab. Collab basically means it will provide some free GPU for some time. You can run simple experiments and some simple Python code in their platform. It's from Google. So once you open this collab .research.google.com, it will show you something like this. You can simply click on new notebook. It will create a notebook for you. So in this notebook, you can do Python coding, and also they will give access to the GPU also. So in the runtime, you have to change the type of the runtime. By default, they will give us the CPU runtime. So, but whenever you want to create any generative AI algorithms, it's better to have a GPU. So I'm clicking change the runtime and also have selected the T4 GPU. All of other GPUs are not available. So from CPU to you have to change it to the T4 GPU. Okay. Once you have changed that T4 GPU, you can simply click save and it will show the connected to the T4. Now we have the access to the GPU. Okay. Now open the link I have provided in the chat section. Once you have opened this web page, just scroll down to their sample code. Here you can have the code for the image generation model. I'm simply copying this code and I'm pasting this one inside the notebook I have created just now. Now I will explain what is this actually was. So diffusers actually this library is from the Hugging Face. So diffusers it will provide a lot of pipeline models for the image generations and communicate with the LLM models and also multi models also they will provide. Like that they have a lot of options in their library. So if you type diffusers, you can find the documentation for the diffusers in the Hugging Face. Can learn a lot of about a lot in their website only. And next, we are reporting the torch library to just to run the model using the TensorFlow, TensorFlow and PyTorch. So actually, what I'm doing was diffusion pipeline. So
Sai, just interrupting 1 minute, Madhav.
yeah,
Can
yeah,
you share the collab link? Raj is asking for the collab link.
okay. Not the collab link. I'm not providing collab link. I'm providing this web page. In this web page, you can scroll down and you can find the Python code. Use it with the diffusions. Oh, I'm sharing the link again.
Yeah, thanks. It works.
You can open that web page and scroll down a little bit. You can find the Python code here.
Yeah, Madhav, go ahead. Yeah.
So you can simply copy this code and paste it in your cell. And you can, once you have connected to the T4 GPU, you can simply start, you can write the whatever the prompt you want to enter and click this run button. It will generate the image. So whenever you are running this code first time, it will actually download the model into your storage. So how it will actually happen is I will show you. So once I run this cell, actually it was saying already I'm having the one runtime. 1 second. So actually, if you see here, so this is the all of the files it was actually I'm run. So it will automatically download the all of the files that's required to generate the model. So these are all model weights. What is the parameters required to the model to run? So all of these files it will automatically generate once you run this diffusion pipeline. Okay. So I will show you. It will take absolutely some time. Okay, we have other demos also. So here I'm selecting this model, Many Dreams. So this is one of the open source model, and I'm using PyTorch floating.16 as a numbers. Uh, And this two CUDA variable, basically what it will do is it will forward the model to the GP. Okay. And also we have other parameters like prompt. Number of inference steps basically means how many number of steps it need to run. Like it's like a epochs in the deep learning. And guidance scale basically means it will show the how much guidance it should take from the prompt. So if you see here, it will start the downloading the files for me. So some files are like 10 GB, 2 GB, like that. It will take some time. The only first time it will take some time. After that, it will automatically fetch the files from the local storage. Okay, this is the width and height of the image. And a clip skip basically means the whatever the prompt you are giving, it will actually embedded by the clip model. So clip model basically from the Google, it was used for the encoding the text into the vector space. So that's why we are using that. And also finally, we will save that image into cat.png file. So let it run for some time. I will show the result. You can show the see the results here. If you click on this folder icon, you can see all of the local files here. Okay. While this was running, I will show other demos also. So some interesting demos. So this is one of most popular demo recent days. So in e-commerce websites, you can see a lot of the models wearing their clothes, and they are showing the products with some models. So it was very time consuming and a very expensive also. Like you have to hire a model and you have to give the clothes to that model. They have to change a lot of clothes, and the photographers will take different pictures. Sometimes the pictures are not perfect. They have to again edit the pictures like that. So recently, researchers have built some generative AI model where they can give the model image as input and also what is the garment they want to apply. So they can give that. And once you select the model, you can simply click the run and it will generate the model image along with this garment. So now let's we try with any model. So I'm selected this model and I'm selecting this t-shirt and simply click the run. So it will take some time to generate that image. See, the wrinkles on the clothes and the neck, everything is so perfect. So if you see this solution as an example, so how many people's burden was actually decreased? The models, the cameramans, the editors, the clothing brand also, they don't have to give those clothes to multiple people and get the shoots get done. So they can simply click the pictures of their clothing and they can, these models also we can generate using the Gen AI, like in stable diffusion and also the focus GitHub repository I have mentioned earlier. With that repository also, you can literally create this model image like with simple prompt, and you can simply give you whatever the garment you want to apply to that model. So like that, you can do that. And also you can do the entire dresses also. Like you can select the model and top wear and bottom wear also you can select. So I'm selecting one model and I'm selecting one top and also one bottom. I think it's only for the either top or bottom, maybe. Okay. You can select the dress also. You will hit the generate button. So like this, it will generate the dress. If I select the model with the dress, then I can select the okay. Sorry, I have to click this images. Okay. Okay, it's generating. See, like this, you can create infinite number of the images for your any e-commerce websites or anything. Like a lot of the e-commerce websites nowadays using this kind of Gen AI solutions for their products also. Not only garments, they are recently using this kind of models for the like accessories, jewelry, and other things also. Okay, this is one example, and I will show the control net example also. I will share this link with in the Google Meet. One second. So this is one another model recently very popular right now. So this is basically means you can upload any image and you can add the text behind the image. For example, I'm selecting this person like this effect you can create. So why this kind of models exist? If you take this as an example, if you want to create this kind of style in Photoshop, it will take some time. Like you have to select this person's head and you have to create another layer Then you have to add the text layer, and then you have to create this one. And still, it was not perfect. So, lot of the YouTubers nowadays creating this kind of thumbnails for their YouTube videos using this kind of Gen AI models. Like they can create this kind of text effects, and they can create anime styles thumbnails also. Like that, they are creating. So this is one another example. You can literally upload your image and try with that. So again, I'm trying with my own image. So we can select the text color also. I'm selecting white. Text thickness also can change position, all of those things. See, like this, you can increase the font size and create this kind of thumbnails also. Okay. I think this was downloaded the files. Yes. We'll just run it again. I think it's already downloaded. Yeah. So what is the prompt I have given? A cat in a bustling Middle Eastern city. So I can simply download this image and see the what is the image it has generated. See, this is generated. So I will just run another prompt here. Can anybody give me any prompt you want to create? Okay, I will take some prompt here and try to generate that one. A dog in spacesuit on street. It will take some time to generate this image. In meantime, I will show the control net example also. So first of all, I will draw a simple drawing. Some mountains, some water, some trees. I will save this image. Now I will upload this one. Create a nature image. I have given this one. This space was not working. Maybe. Okay, I think it's not working. Sorry for the cons. Like if the GPU was not available, it will sometimes fails like this one. So I'm sharing this one also in the chart section. You can try this one also. I'm going to a corporate job. Okay, I will try that once. Are you guys able to run this code in your collab? If you face any issues, you can inform in the chat section. So actually, there is no limit on using these models. Like most of the models are open source model, but you can use them for the personal use only. You can't use them for the commercial use. Some models for the commercial use, you can purchase their license. So if you have the GPU powerful enough to run that model, you can use it as many times you want. In meantime, if you have any questions, we can do that one. And if you want to learn um, more things about the generative computer vision, you can most of the time refer the Hugging Face models, Hugging Face spaces also. And there are a lot of medium blocks available on this space. You can simply type in Google and find out those blocks. Towards AI is one of the best blocks I can found in the um, in Medium, and also in GitHub. Also, they can provide a lot of combination of the generative AI models. And actually, this workshop is provided by the Shihan's Gurukul. So they're actually providing a lot of courses for the people who are actually have educational gap, or they have stopped working on like mothers or some working professionals or someone stuck with their career or anything, or you already in one career, you want to switch to the gen AI field, or you want to switch from testing to any development roles, that kind of things. They are providing a lot of courses in full stack development, AI and data science, and UI UX design. So if you want to interested in joining their courses, I am providing their email address and their website also in this. If you want to contact them, you can contact through email, or you can directly go to their website and inquiry about your requirements. They will provide a lot of good support, and some of the um, people who are teaching there was very experienced people also. So you can refer their website for the more details. If you have any questions, I can answer them.
Thank you, Madhav. So, the guys, like any questions you have, then just ask one by one. Okay, Madhav, you can share your LinkedIn profile link as well, though it is in the event. But like if people wants to like connect to you,
Yeah,
they can
sure.
follow you or any questions they have like later on if they practice this session. So probably they can like connect to you and ask relevant questions.
Yeah, sure, sure. I'm sharing my LinkedIn profile also.
And thank you for the insight given. It is really wonderful.
Thank you. Thank you, guys. Thank you, everyone, for the joining on this session. If you have any doubts regarding while running the code I have provided, you can just ping me in LinkedIn. I will ready to help you, and we will conduct more sessions in future days. So just follow page, then you can join the this session also. Thanks, everyone.
Yeah, and this recording will be uploaded in the YouTube. The link will be provided in the LinkedIn event itself. So if anyone has missed or if you want to, like relook it again or revisit again, just wait for one more day. Probably by tomorrow we will be uploading the link. Thanks everyone for joining. Have a great day ahead.